Vanakkam, Namaste, Namaskar. Welcome back to Jalprayag. Let me do a video on an extension of running fixed principle, which we have already done. So this time I'm going to slightly take a detour out of the normal running fix. And I call this basically a doubling of angle at the bow. So you will see there's a similarity between solving a question using doubling of angle at the bow and the normal running fix, which we have already done before. And as usual, uh, those people who have started seeing the video first time here in my channel, I suggest please go and have a look on the earlier videos which I've been dealing with running fix. So we have done a couple of videos on running fix. So please have a look on that, and it'll be easy for you to correlate between the similarity or the differences of doing a problem with running fix or using doubling of angle at the bow. So let us start off. I call this special condition of running fix. You can say that there are around three cases of special conditions, but I'm going to deal with only two cases here. So I'm going to name first of them as doubling of angle at the bow, and the second one can be called as the 4-point bearing at the bow. Both of these are special conditions. Why I call them special condition is because these two conditions, when I'm trying to solve, I should not involve current and leeway. Why? Because I'm going to take a trigonometric relation, basically a right angle triangle. So that is why keeping a current and leeway will not be able to satisfy the vectors. So we will try to keep out the current and leeway in these two conditions. So let us have a look. And for that, I'm going to take an example to start with. So I'm going to give you an example with some values. Let us say I was sailing, and I could see one lighthouse at 8 o'clock was bearing 045 true. And let us say after 1 hour, the same lighthouse was 0000 degree true, which is true north. At the same time, my vessel was sailing a course of 090 with a speed of 12 knots. Now, my job in this question is, as I said, is a special case of running fix. Normally, you will try to find the two positions, 8 o'clock and 9 o'clock position. And in case the forces were given, I would complete a triangle and finish off the question. But here, I've mentioned again on the title itself, special condition should not have current and wind. So let us go ahead with this question as a recap, how I will go and solve this using a normal running fix principle. So I would have taken the lighthouse, plot the first bearing at 8 o'clock, plotted the second bearing at 8 o'clock. Sorry, I'm 9 o'clock. And I'm going to solve this question by a simple running fix. So what you would have done was, I would have assumed a position alpha in the first bearing anywhere. I would have plotted my course steered, which is 090. Since the two bearings are having a duration of 1 hour, I will take 12 nautical miles, mark Bravo, transfer the first PL, which is your 8 o'clock PL, to Bravo. Wherever it intersects, I'm going to get 9 o'clock fix. That is the green color circle which I've shown you. I'm going to retrace my course steered, which is 090, go back, intersect on the first PL, and I'll get my 8 o'clock fix. So this would have been my normal procedure for doing a running fix problem. And any question which I'm telling you, like doubling of angle, can be done by this method also. But let us see what is the difference, what are the advantages. Sometimes the question will be posed in such a way that you will be forced to do with the doubling of angle principle. So you need to know this principle also. I'm going to show you quickly on the chart exactly the same thing of running fix. so it's nothing new. I'm just repeating. So I'll be a little bit fast. So two bearings. I've already mentioned, please do not draw this bearings in the wrong direction. Alpha on the first bearing, course steered, mark 12 nautical miles, that is Bravo. Transfer your first PL. Intersection is your second fix. Retrace your course steered. Intersection on the first PL is your first fix. And these are the two course steered. I don't have any current and wind. So the vessel would have sailed like this. These are the original two positions of your vessel. Now, exactly the same question. I'm going to look at a different perspective. So I'm going to change the way we look at it. So I'm going to relook at the same question. Let us look at 8 o'clock. And this is where I'm going to take use of the compass rose, which always helps you to understand much better. So I'm going to take a compass rose. I'm going to put myself with my course as 090. This question told me that at 8 o'clock, the lighthouse was bearing 045 degree true. So the lighthouse should have been here. I put 045. I'm not going to take these bearings and my heading as a reference. I'm going to look in some other way. I'm going to look at what is the angle of this lighthouse at 8 o'clock on my bow. That means from my bow, what is the angle? You will see the answer is 45 degrees. Please do not write 045, it is 45 degrees. Now again in the same question, let us look at 9 o'clock. The same vessel, when I was sailing the same course at 9 o'clock, was here, due north, and this was the bearing. Now again, I'm going to look at the bow angle. The bow angle, please remember right now is 90 degrees. Please do not write 090, it is 90 degrees. So I have found out something new here. Instead of talking about the bearings and everything, I am talking about angle at the bow. So let us proceed with the same question. Okay, it's exactly the same. So I'm going to rephrase the same question. Let us say the vessel was sailing like this. These were the two positions somewhere approximate on those two bearings. But I'm going to look at a different perspective now. Let me look at the angle at the bow. So your angle at the bow, just now we saw on the compass rose, it was deduced as 45 and 90 degrees. So this is going to be 45 and this is going to be 90 degrees. Something what you should realize is by doing this particular course and this lighthouse, I have achieved something. What have I achieved? I have doubled the angle at the bow in 1 hour. So the angles have doubled. So let us see this markings of A, B, and X. If you realize, I have formed actually a kind of a right angle triangle, ABX, where your Bravo is 90 degrees, alpha inner angle is 45 degrees. So if you try to form a trigonometric relation here, I can form something called tan 45, and tan 45 is 1. And if you try to look what is tan, let us quickly look what is tan. Tan is basically opposite by adjacent side. And since tan 45 is 1, opposite and adjacent have to be same to get the answer 1. So the opposite side and the adjacent side, which is your AB and your XB, have to be equal. This is your opposite, this is your adjacent. Provided there is no current and no wind. Why? Because I'm trying to form a right angle triangle. And coincidentally, in this particular question, you should realize something, that when my vessel is at Bravo, the distance called Bravo X-ray or X-ray Bravo is also the beam distance in this case. So this is something which will be useful for you in the question. This is a beam distance also. Let us proceed further and see something more. So we have already seen tan 45 is equal to 1. Opposite side and the adjacent side have to be equal. So AB is equal to XB. So this distance AB has to be equal to XB. which also means the distance traveled by the vessel by engines from 8 to 9 o'clock, which is AB, is 12 nautical miles. And it's very, very evident that at 9 o'clock, the distance between the vessel and the lighthouse, which is XB, is also exactly 12 nautical miles. So this is what we have achieved by looking at this doubling of angle principle in a different way, rather than going by a normal running fixed principle. So I have written mark this 12 nautical miles and 12 nautical miles. This one picture clearly shows you AB is equal to XB, both are 12 nautical miles. It is tan 45. The same problem could have been done by a normal running fixed method also, as we have seen earlier. I can club that diagram here also. Let us say I start from this point, plot my 12 nautical miles, arrive at a different point, 12 nautical miles. I retransfer my first PL, which is here, transferred PL. You will see, you will get exactly the same answers. So, as I said, this question can be solved by both methods, but there are slight advantages of going by doubling of angle, provided you don't have current and wind. So let us quickly have a look on how I can use this method in a slight easier way and plot faster than your running fixed method. Let us go on the same question. So the question was given to you as 09012 knots is your course and speed, and 8 o'clock 045, 9 o'clock is your 000. That was the bearing given to you. The moment you realize by looking at the question itself that I have already doubled the angle, my first thing should go is distance traveled in that 1 hour by engines is exactly going to be the distance of from me to that lighthouse at 9 o'clock. So that means I know something already. The chart is empty. The chart, please remember, has only got the lighthouse. I'm not going to draw just like the running fix. I'm going to go in a reverse method by this concept of AB is equal to XB. So, which clearly means that I can use this 12 nautical miles directly from the second bearing. Okay, directly from the second bearing. So, I'm going to draw the second bearing first. This is your second bearing at 9 o'clock. I know at 9 o'clock the distance off is equal to distance sailed between last 1 hour, which is 12 nautical miles. I'm going to take my compass. 12 nautical miles, I'm going to cut an arc. So this is going to be my fix at 9 o'clock. The moment I know this, I know what I have sailed in last 1 hour. It is 090. So I'm going to mark my CTS in the reverse. And this distance also exactly the same as distance of XB is equal to AB. I'm going to cut an arc again with 12 nautical miles from the 9 o'clock fix. That gives me 8 o'clock fix. And if you see, this distance AB is equal to XB. For the ease of completing question, I can always join these two and you will get your original 8 o'clock bearing also. So this is how you can approach a doubling of angle at the bow rather than going by normal running fixed method. Okay. Again, as usual, XB is coincidentally the beam distance also for the vessel, which in case I want to use in some question, I can always use. You will see these kind of questions may come in day's work problem for your basics, that is your DNS, BSc first year. It is there in your second med syllabus also in exams. So you may be given a question like this. So for you, you should know this doubling of angle principle. You'll be forced to do with this method because he will not give you your initial fix, or some data will be missing for you to do a running fix method. The same question I'm showing you on the chart. Since I know distance traveled is equal to distance off, so I go to the lighthouse, directly draw the second bearing at 9 o'clock. I take 12 nautical miles and cut an arc. I get my 9 o'clock fix. I draw my CTS and cut an arc on that also, and I get my 8 o'clock fix. For the sake of showing you that the bearings are right, I can join these two. That will give you 045. And the vessel was sailing like this. So this can be exactly solved the same way as we did in running fix. You will get exactly the same answer. Okay, but there are some advantages of doubling of angle, and I said some questions will force you to do with this method. So try to use this method where you're looking at the second bearing and the distance of first before plotting the rest of the things. Okay. Now I'm going to show you the second special condition which I had talked. It was called 4-point bearing. Okay, which was called 4-point bearing. I'm going to use the same question because this question satisfies the 4-point bearing concept also. Now, there is nothing great for me to explain in 4-point bearing. All I'm going to do is just point out and highlight that at my first 8 o'clock position, the vessel was sailing 090 and the lighthouse was 045. So that means I had 45 degrees on the port bow. 45 degrees is also 4 points on the port bow. So that is why this particular question and the case can also be called as 4-point bearing problem. So there is nothing different from what we did earlier and what we have done now. So that's it. This 4-point bearing has got nothing great about it to understand. It's just simple extension. I'm going to, before I go to a different case or a different example, I'm going to quickly show you some values on the compass rose. Let me say that at 8 o'clock, I was still doing 090, but this time the lighthouse was bearing 060. Okay. So please look at the bow angle that is going to be 30 degrees. I'm going to use this example in the next question. Let us look at 9 o'clock. Same, but this time the bearing of the lighthouse was 030. Please look at the bow angle. So try to correlate with the previous slide and this slide. Last slide was bow angle 30 degrees. This slide bow angle is 60 degrees. I'm going to give you a question now, which is again a doubling of angle principle. Please see this. I am sailing. I could see a lighthouse at 8 o'clock 060. So I have drawn 060. At 9 o'clock, I saw the same lighthouse 030 degrees true. I was sailing 090. So I would have been sailing somewhat like this. You can see here the angle at the bow at 8 and 9 are again 30 and 60, which means they have doubled. The last question was slightly easier. Why? Because I had tan 45, so it was a pure right angle triangle. But you can see this is not a right angle triangle. So how can I approach this? Let us quickly have a look on the inner angles of this particular triangle. Let us have a look on that. Okay. So angles have doubled, which we have proven. I'm looking at this inner angle. Please see this inner angle at Bravo is going to be 180 minus 60 degrees. The outer angle is 60. So it has to be 120 degrees. Now, I have two inner angles already with me. One is your alpha, which is 30 degrees inner angle. Bravo is 120 degrees inner angle. Then X-ray, I need one more inner angle. So a simple guess will tell you that 180 minus this will give you again a 30 degrees. Okay. So if you look at this triangle, ABX, you have formed an isosceles triangle, which means two sides are equal, and hence two angles also will be equal. So as per geometry, if two angles are equal, like I have 30 and 30, the opposite sides of this triangle also will be equal, which means again AB is equal to XB. Again AB is equal to XB, which means this is AB and this is XB. So this is the easiest way to understand. I can do a different way also. I'm going to show you in the coming slides. So isosceles triangle was again easy. AB is equal to XB. Okay. So let us say the distance traveled in 1 hour was 12 nautical miles. So AB is equal to 12. Obviously, our XB is also going to be 12 nautical miles. Okay. And this particular relation can be proven by extending my course, which is your alpha bravo. I will extend it and I can complete this as a right angle triangle by giving one more point called Yankee. So you can see X-ray Yankee, I have extended and formed triangles. And now you can form two right angle triangles, which is your AYX and BYX. You can solve this way also and you can get answer. Many of the problems in chart work will need you to extend this and solve the problem. So please think about it. Keep this in mind. It's a doubling of angle, but I can extend it as a right angle also. Or otherwise, I can solve by isosceles. Now, the same question can be given in various sets of angles. As far as I double the angle, I satisfy this condition. So I've given you one set as 15 and 30. So alpha could be 15 degrees and bravo could be, bow angle could be 30. It could be 20, 40, could be 25, 50, 30, 60, and 45, 90, etc. If you ask me, there are unlimited combinations you can do if you want. It can be 22, 42 also. So it can be 33, 66 also. All of them you will be able to satisfy this doubling of angle because they will be forming an isosceles triangle. So this is the concept of doubling of angle at the bow. I hope it was easy to understand. It's a very basic concept which comes as a part of a question within a main question. It could be a separate question for maybe BSc first years and DNS. But when you come to second mates and mates, this is always a part of your question. And as I told you earlier, this concept can be used in days work question where you'll have limited data. So you cannot use the running fixed principle. You'll have to go by the doubling of angle. Anyway, that's it for today. I'll catch you soon with a new video again, most probably with the chart work as soon as possible. Until then, keep watching Jal Prayag and Vanakkam, Namaste, Namaskar.